Hello and welcome. Today I want to introduce the Telescopio Nazionale Galileo TNG, which is in a very beautiful place on La Palma. As you can see here, the cupola has this modern layout that many modern telescopes have, and it has a bridge. Why does it have a bridge? Probably not for the astronomers to go inside, but probably the telescope was transported on this bridge to be put into the cupola. But it's very characteristic in case you are there and want to find out which one of the telescopes is TNG. As always in these presentations, I have the same structure: history and purpose, motivation, then the equipment, the geography. I think this is the first telescope on La Palma that I'm introducing, and notable results, and I also packed some of the results into the summary and outlook slide. So the owner is really a national Italian telescope. The owner is the Consorzio Nazionale per l'Astronomia e l'Astrofisica, CNAA, and / Galileo Galilei Center, which the Italians of course are very proud of Galileo, who many people think invented the telescope. No, but he was one of the first to apply a telescope on the starry sky. Now it's called Galileo Galilei Foundation, and they got money from the INAF also. The observatory was opened in 1998, and here I mentioned the EIE group. We have seen this company earlier in another observatory to build the structure of the telescope. The TNG is very active in exoplanet research, and I will show you which instrument has been breakthrough in that. Later I'm going to show you the Kepler 78b and Gliese 625. On the webpage they said the discovery of Kepler 78b, but I don't think that the TNG discovered it. It characterized and helped to establish its mass and this kind of thing. It's more logical that Kepler 78b was actually discovered by Kepler. And it helped to characterize asteroid 2012 DA14. I'm going to show you this in a second, why this is an important asteroid. The aims of the telescope were to observe high redshift galaxies and star formation, and also study minor bodies in the solar system, like for example this one. Then do some galaxy studies in general, and cosmology, and also planets. So it has a very broad range of applications. The telescope itself is a 3.58 meters Ritchie-Chrétien with a f of 10.8, and it has a 0.87 meter secondary mirror. This telescope is actually derived from the entity. I wouldn't say a copy of the new technology telescope, but it is very similar. So it also has active and adaptive optics, something that was used the first time with the entity. That was a very important step for the European Southern Observatory to be able to build very large telescope, and finally also the extremely large telescope. that will open soon. And from the instruments that the telescope has, especially the one on top, the HARPS, the visible light shell spectrograph, is very famous. You can see that some of the instruments work in the visible and some work in the near infrared. And there's also photometer. The HARPS is needed too for spectroscopy. And we'll see what that means. The geography, the telescope is on the Roque de los Muchachos in La Palma. And as you can see here in Google Maps, La Palma is an island that consists more or less of this volcano. Actually, could turn out as a bit of a problem because the volcano isn't extinct. It has been showing some activity recently. I hope it won't destroy all these large telescopes there. For example, you can see close to the TNG there's also the Gran Telescopio Canarias, which is certainly the biggest telescope in Europe, but depending on how you count, also the biggest on Earth, biggest single mirror so far before the three large ones are finished. And it is 28 degrees north, and I always tell you that 20 north is optimal. So 28 already goes a bit into the west wind zone because the eternal high pressure zone is very small. So this could play out in North winter. Maybe it loses some nights in winter because of that. But it's still very good, as you have seen on the first picture I've shown you. It shows exactly this Hawaii type weather, typical weather with fog over the sea, and the volcano is able to be on top of the fog, which makes then the air very clean. One thing that the telescope did is characterize the asteroid 2012 DA14, or later it was called Duende. It is an important asteroid because it's actually crossing the plane of the ecliptic very close to the Earth. So it was thought that it could actually hit the Earth in 2026 or in 2069. So when it came close in 2012, 2013, people wanted to characterize the asteroid, and they did it in two ways. One was the Goldstone radar that found that it was a fairly elongated object, but also the TNG measured it at the light curve, and it was put into a series of predicted use. Of course, the telescope isn't able to see the object resoluted, but it looked at the light curves, and from the light curves predicted the form of the object. And here there are some data on the Duende. It is an L-type asteroid, and it has a rotation period of just a little below 9 hours, which is quite a fast rotation for an asteroid. Sometimes they spin up for some reason. maybe also some outgassing or something, because it's coming close to, relatively close to the sun, then they can speed up. And sometimes then, if the speed grows too high, they can split like a comet. Then another object the telescope is well known for is Kepler 78b. Kepler was this satellite, it's coming up again and again in this series, and it was staring in this point of the sky. Each of these squares has to do with the CCD camera, or that was used. So there's a little gap between parts of the CCD, and it was looking to the swan, into the one wing of the swan very close to Lyra also. And that's these days the easiest way of discovering some random exoplanets. In the past, people used rather the radial velocity method, and now most exoplanets are discovered by passing in front of the star, which of course taps only the planets that are accidentally exactly in that orientation, that we can see them in front of the star, which won't happen to many, and it will happen only if the planet is very close to the star. But then once that happens, you have to determine its mass, and it can't be determined with that method. So then people use the radial velocity method that can be applied in any orientation. Just the mass of the planet has to be large enough to make the star, its mother star, wobble enough for the spectroscope to be able to detect the movement. So it works well for large planets and heavy planets and light stars, actually. And similarly, it observed also Gliese 625b, which is a super Earth that is going around an M25 type star, so probably quite a small star, located in Draco. And here the data are given, the right ascension, declination, the apparent magnitude, so it would be possible to see the star in relatively small telescopes with 10 magnitudes. And the distance is relatively close with 21 light years. And the star has just a quarter of the solar mass. They even give the surface gravity and everything. Yeah. So, as a summary, this telescope does mainly spectroscopy, which is true for most large telescopes, actually. It has been put a lot of work into exoplanet search and characterization with the radial velocity method, with this HARPS spectrometer, and the same has been used for seismology, which is something then that has been used to characterize the inside of the sun, but it can be applied also to other stars these days, and also worked in variable stars and verifying X-ray and gamma sources which we have seen in other infrared telescopes too. And it looked at quasars and galaxy clusters. And as we have seen, a rapid response to characterize near-Earth objects. And the observatory lists roughly 100 papers or more a year, which means it is a quite productive institution to get data for papers. And thanks a lot for the attention.